question number 3. We're going to state the possible number of real zeros and the number of turning points for each function, and then we'll determine all the real zeros by factoring. So in 3a, it's a 6-degree polynomial, so because it's a 6-degree polynomial, it has a total possible, doesn't mean that they are, but there's a possibility that it can have 6 real zeros, 5, 4, 3, 2, 1, and 0. Because it's even, it could miss the axis completely. Number of turning points, if it's an even function, it always has an odd number of turning points, so the maximum number of turning points it could have is 5, or any odd power below that, or not odd power, but 5, and then minus 2 for each one of those. So either it's 5, 3, or 1 turning point for a 6-degree polynomial. Now the real zeros, in order to get the real zeros, I'm going to have to first figure out what the factorization of this is. So we have x to the 6th minus 8x to the 5th plus 12x to the 4th. And factoring this, what we'd want to do is factor out our x to the 4th. That's in common to all of them. That'll give me an x squared minus 8x plus 12. And then that quadratic factor factors again as well. So my factored form will be x to the 4th times x and x, 12. The factors of 12, they have to be the same sign, so minus and minus are going to be 6 and 2. So there's the factored form that they're after. So rather than rewriting, I'm just going to go like this. And then the number and the real zeros that we have, what are the values of this that will create an output of 0? So that's if x is equal to 0. So this one, when x is 0, when x is equal to a 6 here, and the last one is when x is equal to a 2. So our zeros are 0, 6, and 2. So if I put them in order, it just goes 0, 2, 6. So that's 3a.